Hi, in this video we're going to discuss exponential location and scale families of densities or mass functions. And we also focus on this result given as Theorem 26 in our instructional materials, where the theorem presented another way of computing the expected value and the variance of a random variable. So we will talk about that in detail later. So we start first with the definition of the one parameter exponential family of densities or mass functions as given in definition 41. So a PDF or PMF, which is denoted by small f sub x, which is a function of the parameter theta, which is unknown, is defined to belong to the one parameter exponential family of densities. That's for the case of continuous random variables, or the one parameter exponential family of mass functions. There's a typo there. Mass should be double S, and that's the case where the random variable or the distribution is for the discrete random variable. Okay, so f sub x of that theta is said to belong to the one parameter exponential family if and only if we can express that as follows. So we can write f sub x of that theta as the product of a theta. So that's a function of the parameter theta alone. Then we have b of x, a function of x alone, and then times the exponential of a function of theta alone times a function of x alone. So c theta times dx for all theta in the parameter space omega sub theta, where the function a theta should be positive and the function b of x is also positive for all x, such that f sub x of x theta is greater than 0. Ayan. So, ang gagawin lang natin is that if given the density function or the mass function of the random variable, para malaman natin if that particular function belongs to the one parameter exponential family of densities or mass functions, we must be able to express the given density function or mass function as the product of these three expressions. So we have here in example 35 some distributions that belong to the one parameter exponential family of PDFs or PMFs. So in number 1, we have the Bernoulli with parameter p and the geometric distribution with parameter p. Number 2, we have the Poisson distribution with parameter lambda, and in number 3 we have exponential. So the first two examples, the Bernoulli, geometric, and the Poisson are discrete distributions. And also number 5, the binomial NP, where n is known. And then 3 and 4 are examples of continuous distribution, so this or density functions that belong to the one parameter exponential family of PDFs or PMFs. So let's show number 1, in particular the Bernoulli distribution, that we have if x follows the Bernoulli distribution with parameter p, then it's let's just write its mass function as f sub x of x which is a function of the parameter p, is equal to that's p to the x times p raised to x times 1 minus p raised to 1 minus x times the indicator, that x is either 0 or 1. So we're going to show that this function right here may be written as product of, or as the product of some function of theta alone. In this case, our theta is p. Let me just write theta here. The parameter theta, which is the one used in definition 41, is actually p. Okay, so we must be able to write this as a function of the parameter p times a function of x alone and an exponential of the product of a function of the parameter p and of x alone. So a key concept here, or result that we're going to use, is that of the exponential and the logarithmic function property. We know that e to the ln of x is just equal to x because e and ln are inverse functions. So ito yung gagamitin natin. Yan na result. So that we can write this one as p to the x, and then we have 1 minus p raised to 1 all over 1 minus p raised to x. So that is just 1 minus p raised to 1 minus x. So, and then we have I 0, 1 of x, the indicator function, and then we will group these two terms here. I mean these expressions p to the x and minus p to the x, so we can simplify them. Thus we can write the mass function into 1 minus p times p divided by 1 minus p, this expression raised to the power x, times I 0, 1 of x. And then I'm going to write the expression p to the p all over 1 minus p to the x as let me follow first the indicator function. Okay, so i-erase natin yan siya. We make this I mean we're going to use this result here, that e to the ln x is just equal to x. So if we think of p all over 1 minus p to the x as our x here, so we can actually write this one as the exponential of the ln of p times 1 minus p to the x. Okay. And then apply the property of logarithm. We'll have, let me just move this here, 1 minus p times I 0, 1 of x. Okay, so this will now be our a of theta, and this is positive. Why? Because in the Bernoulli distribution p is from 0 to 1, so 1 minus p is greater than 0. And this is also positive, or 0, the indicator function, sorry. This will be our what's our notation? b of x. And then we have x times ln of p over 1 minus p. So no, I'm gonna write first this one. We have ln of p times x. Yeah. So that this will be our c of theta. Instead of theta, I'm gonna use p now. So c of p And this is our d of x. Therefore, since we have written the mass function or the Bernoulli mass function into a of p times b of x times c of the exponential of c of p times d of x, then we say that the Bernoulli p distribution belongs to the one parameter exponential family of mass function. So in this case, the parameter is p. Again, the key concept na ginamit natin is ito. Why? Kasi wala namang exponential kasi dun sa diba, walang exponential function na makikita dito sa mass function ng Bernoulli P. So, yung exponential family, dapat meron tayong exponential of c of theta times d of x dyan eh. Kaya gagamitin natin yan. Ito. Okay. So, you can do the same for the geometric P. I'm going to show dun sa itong Poisson. Lambda. Ano yung mass function nito? The sum. No. Is it the sum? It's lambda. This is not p, this should be lambda. It's lambda to the x times e to the minus lambda x all over x factorial times the indicator function okay. So dito meron tayong exponential function involved in the mass function, so pwedeng hindi na natin gamitin tong e to the ln x. So all we have to do is to identify our a of lambda, b of x, I'm sorry, walang x dito pala. It's just e to the minus lambda. So lambda to the x, e to the minus lambda divided by x factorial. That's the density of the Poisson distributed random variable with parameter lambda. Okay. So separate natin paano ito? Isulat natin tong e to the minus lambda. This will be our a of lambda. And then we have the indicator function 0. Kailangan pa rin. Sorry. Since walang x pala dito sa exponential function na to, kailangan pa rin pala natin gamitin ito na result. Anyway, susulat ko na lang to 1 tapos x, tapos yung lambda to the x isusulat natin siyang e to the ln of lambda to the x. So ito yung magiging kulang pa to ng x factorial, nakalimutan natin yung x factorial, so iangat ko lang siya ng konti. That will be divided by x factorial. Ito yung magiging b of x natin, that's positive. And ito naman, isusulat natin siyang, ma-write natin yung PMF into e to the minus lambda. Tapos, copyin ko lang to. And yung e to the ln of lambda x will be e to the exponential. Dito ko lang, gawin ko lang e to the x, ln of lambda times x. So, ang a of lambda natin is equal to e to the minus lambda b of x is equal to this one. Tapos, yung c of lambda is equal to ln of lambda. And d of x is equal to x. Therefore, the Poisson mass function belongs to the one-parameter exponential family of mass function. Next, we have if x is exponential lambda, then f sub x of x lambda is equal to lambda e to the minus lambda x I 0 to infinity of x. Ayan. So, no need, ito dito, yung hindi na kailangan nating gamitin ito na result. So, in that case, ano yung a lambda natin dito? Ang a lambda natin is itong lambda. Of course, that's positive. Yan yung requirement sa exponential eh. Lambda is greater than 0. Ang b of x natin is yung indicator function. Tapos, yung c of lambda natin is pwedeng negative lambda. And then, yung d of x natin is cx. Okay, so, for the normal and the binomial distribution, exercise na yun, class. Okay, now, in definition 42, binigay naman yung definition ng k-parameter exponential family of densities or mass functions. So, yung unang definition kasi kapag isang parameter lang yung nasa PMF or sa PDF. Pag more than one parameter, iba naman. Medyo similar lang. Extend lang natin yung idea. So, a PDF or PMF, f sub x, which is a function of several parameters. So, we denote that by theta underscore. So, in the definition, we assume that there are k parameters involved, which are all unknown. So, that PDF or PMF is defined to belong to the k-parameter exponential family of densities or mass functions if and only if we can write the density as a function alone of the parameters. So, a of theta underscore times a function of x, b of x, times the exponential of the sum from 1 to k of a function of theta underscore times a function of x. Ganyan. Again, yung a of theta is positive, yung b of x is positive for all x where f of x is greater than 0. Examples niyan are the normal, the general normal with mean mu and variance sigma squared, the beta with parameters a and b, the gamma with parameters r, lambda. So, to show that these distributions belong to the two parameter, dalawa lang kasi mga parameters in all these examples. So, to show that these three PDFs belong to the two-parameter exponential family, dapat alam natin kung ano yung mga density functions nila. And then, yun nga, we have to write their density functions as in the expression given in definition 42. Okay. So let's let's show for the general normal. Yan. K parameter exponential family of densities or mass functions. So you have number 1, we have n mu sigma squared. Okay, so in this case, the density, which is a function of the parameters mu and sigma squared when both are unknown, is this 1 over square root of 2 pi times sigma times e to the negative 1/2 of x minus mu over sigma quantity squared I r of x. Okay. So, meron tayong exponential dito, function, tapos yung exponent niya is negative 1/2 x minus mu all over sigma squared. So, expand natin yan. Magiging x squared minus 2 mu x plus mu squared all over sigma squared I r of x. Okay. So, ano yung kailangan natin? Dapat meron tayong a of the parameter. A function of the parameter. Parameters, rather. So, dito yung parameters natin are theta and sigma squared. Okay, so we have i-factor out natin itong e to the negative mu squared over 2 sigma squared. So, meron tayong e to the negative mu squared over 2, and then we have anahin ko muna itong I r of x. Tapos we have e to the negative 1/2 of x squared sigma squared minus ito na lang kasi may iwan, di ba? Ito na lang may iwan kasi nilabas na natin yung mu squared dito. So, pag dinistribute natin yan, magiging plus na pala, negative of negative. So, plus, madidivide na yung 2. So, mu x. Mu over sigma squared times x. Okay. Ganito na lang. Ito, i-write ko na lang to. Itong term na to. Into negative 1 over 2 sigma squared times x squared. Ayan, para mas clear. So, in this case, ano yung a of theta? Ano yung a of mu sigma squared natin? Ito yon. Tapos, yung b of x natin will be yung indicator function I sub r of x. Tapos, dito, tingnan natin ito. Tingnan natin yan. Exponent ng e. Dapat masulat daw yan as a sum. Nakasum naman yan, di ba? Sum ng function of parameter times x. Okay, which is true naman kasi, di ba ito? Parameter, function of parameter, tas x squared. Function of parameters times a function of x. So, a function of the parameters times a function of x. Function of parameters times a function of x. So, in that case, pwede nating sabihin na yung C1 of mu sigma squared natin is equal to negative 1 over 2 sigma squared, tapos yung d1 of x is equal to x squared. Tapos pag c2 of mu sigma squared natin is mu over sigma squared, then magiging d2 of x natin is x. Or pwedeng ito naman dito, sila yung mga nakasubscript ng 1, ito naman sila yung nakasubscript ng 2. So, okay lang yun. Therefore, the n mu sigma squared belongs to the 2-parameter exponential family of densities. So, kung titingnan niyo, since dalawa lang yung parameters, dapat dalawa din yung ano dito, yung sa sum natin dito. Yan. Dalawang terms din dapat na product ng function of parameters times the function of x. Okay? So, ayan, you can do the same for the beta AB and the gamma R lambda. So, dapat alam nyo yung forma ng density functions ng dalawa yan. So, that will be left as an exercise to you guys. Okay, so proceed tayo dito sa theorem 26. Lakihan ko lang tong IM natin. Ano ba tong theorem 26? So, if x daw is a random variable whose PDF belongs to the k-parameter exponential family, then, yung expected value nung sum from 1 to k of the partial derivatives with respect to each parameter theta j times di of x is just equal to the negative of the partial derivative with respect to theta j of the ln of a of theta underscore. Ayan. While the variance of that same expression in equation 4.24 is equal to the negative of the second partial with respect to theta j of ln of a theta underscore minus the expected value of the sum from 1 to k of the second partial of ci theta times di of x with respect to theta j. Okay, so using these results, we can derive the mean and the variance of a random variable whose density or mass function belongs to the k-parameter exponential family. So, kasama na dito yung 1-parameter class ha. And mas general kasi ito na definition, yung k-parameter exponential family. So, to illustrate that, consider natin si binomial NP. So, if x has the binomial NP distribution where n is fixed, then its mass function is given by n taken x times p to the x times 1 minus p to the n minus x times the indicator function I sub 0, 1 to n of x. So that means x can take on only the values 0 to n. The integers 0 to n. Baka sabihin yung interval. And then we can rewrite that into, kasi i-show muna natin that this PMF belongs to the k parameter. So in this case, since n is fixed, we only have one parameter, yung p lang. So we show that p of x belongs to the 1-parameter exponential family. So isulat natin rewrite natin yung PMF into 1 minus p to the n times n taken x times the indicator function. Tapos, i-group natin yung p to the x at saka yung 1 minus p to the negative x. Ayun, just like yung yung ginawa natin kanina sa Bernoulli. 'Di ba? Present yung without n taken x lang naman, parang Bernoulli lang yung So, meron tayong exponential of x times ln of p over 1 minus p. So, in that case, our a of p is 1 minus p to the n. Ang b natin is yung n taken x times the indicator function. Ang c natin is yung ln of p over 1 minus p. At saka yung lastly, d of x natin is x. Okay, so gawin natin yung or kunin natin yung partial. Isa lang naman yung parameter dito. So, we get the partial with respect to P of C of P times D of X. So, yung C of P times D of X natin, ito yung X ln of P over 1 minus P. So, differentiate natin yan with respect to the parameter P. That will be, ano lang kasi yan, apply yung property ng ln. So, ln of the quotient is just, yan. Tama ba yan? ln P minus ln of 1 minus P. Yan. So, differentiate yun. Derivative ng ln P is 1 over P. Derivative ng ln of 1 minus P is the negative of 1 over 1 minus P. So, since may minus kanina, kaya naging plus, yan siya. Yung X, constant lang yan siya with respect to P, kaya naging merong X lang sa labas. Okay, tas kunin natin yung second partial derivative with respect to P. So, i-differentiate lang natin itong first partial with respect to P para makuha yung second derivative. So, makukuha natin will be negative of X times 1 minus 2P all over P squared times 1 minus P squared. So, algebra lang yan, class, ha. I-review nyo na lang yung kung paano mag-differentiate. Okay, or paano kunin yung derivative ng isang function. Okay. Yan yun. Now, kunin muna natin yung ln ng A of P. So, since A of P is 1 minus P to the n, then pag i-ln natin siya, magiging n times ln of 1 minus P. Therefore, the partial of that with respect to P is equal to the negative of n times 1 minus P. And the second partial of that with respect to P, or partial squared all over partial P squared, is equal to the negative of n all over 1 minus P squared. So, yung sa equation 4.24, yung sum from 1 to k, isang term lang yun, class. Kasi one parameter lang naman eh. Dito kasi, general kasi yung binigay dun sa result para sa k parameter exponential family. So, since we have shown that yung binomial NP belongs to the one parameter, so yung summation dito, isang term lang. So, ano lang, partial of C theta with respect to theta. In this case, our theta is P. Kaya naging partial with respect to P of C of P times yung D of X. Okay. Yan. So, expected value ng ano yung D of X natin? Ano yung D of X? Diba X? Kaya, since pag expectation kasi dapat random variable, kaya nakakapital yan. So, capital X all over, yung partial with respect to P, ano yun? Ng C of P. Ano yung C of P natin? ln of P over 1 minus P. So, yung partial niya with respect to P is 1 over, ayun, kinuha na natin 1 over P times 1 minus P. Ang random dito is yung X. Yung parameter P is constant or fixed yan siya. Or, yeah. So, pwede natin siyang ilabas doon sa expectation operator. Kaya naiwan na lang yung expected value of X. So, kaya naging 1, yung expectation ng partial with respect to P of C of P times D of X is just 1 all over P times 1 minus P times E of X. Now, according to equation 4.24, equal daw siya sa yung negative, the negative of the partial with respect to P of ln of AP. Kinuha na rin natin yan kanina. Yung partial with respect to P of ln of AP is negative n over 1 minus P. So, since naka-negative to dito, multiply yan by negative 1, kaya natanggal yung negative sign, class. Kaya, meron tayong E of X over, or E of X times 1 over P times 1 minus P is equal to N over 1 minus P. Provided that 1 minus P is not equal to 0, pwede natin siyang i-cancel. Kaya, when we solve for E of X, we will get NP na lang. Okay? I hope you can follow that. Tapos, for the variance, gagamitin natin yung equation 4.25, syempre. So to solve for the variance, kailangan natin makuha yung variance ng partial ng C of P with respect to P times dx, or the variance of x all over P times 1 minus P. Again, constant lang. Hindi naman random si P times 1 minus P. Then applying the property of the variance, maiwan yung random variable x, pero mas square yung constant natin. Kaya naging var of x times 1 all over P squared times 1 minus P squared. Tapos, equal naman yan siya dun sa ito, dalawang terms yan. Negative of the second partial with respect to theta squared of ln of 8 theta. Kaya kinuha natin kanina yung second partial, di ba? If you go back here sa line na to, yung negative, the partial with respect to P of ln of A of P, and the second partial with respect to P of, that is negative n over 1 minus P squared. So, yan yung isa-substitute natin dito. Pero naka-negative yan. So, in-negative natin yan, magiging ano yan, n over, positive na yan, n over 1 minus P squared plus, bakit naka-plus na yan? Kasi minus expectation yan siya ng second partial ng C of theta times D of x. So, saan yung C natin? Yung C of theta natin is ln of P. So, sulat ko na lang muna dito. Yung C of P natin, that's for, ano example ba to? Example 37. So, this is from example 37. Ang C of P natin is ln of P over 1 minus P. So, the partial with respect to P of C of P is equal to 1 over P times P over 1 minus P times the derivative of P all over 1 minus P is low d high. So 1 minus P times 1 minus high d low, negative 1. 1 minus P squared. Simplify that. We have 1 minus P times 1 minus P plus P 1 minus P squared. So cancel itong isa dito, maging 1 na lang yan. 1 minus P plus P is 1. So 1 over P times 1 minus P. Kaya ayan yun. Yung second partial niyan, differentiate again natin ito para makuha yung second derivative. So, low d high is 0. So, P times 1 minus P times 0 minus high d low minus 1. Ang derivative ng low is product rule. So, P times negative 1 plus 1 times 1 minus P all over the square of low. So P squared 1 minus P squared. So that's 0. So that's the negative of negative P plus 1 minus P so that will be the negative of 1 minus 2P, tama? P squared 1 minus P squared. Okay, so ano nang next? Ayan. Negative yung ln of a theta, nakuha na natin yung ano nun, second derivative. Kaya yun, meron na tayong n over 1 minus p squared plus